Hi everyone, I'm Shubhanshu, and on behalf of my co-authors, I'll be presenting our work on NTULM, enriching social media text representations with non-textual units. First, we identify NTUs as context of a text-based social media post. In tweets, NTUs can either be embedded inside the text, for example, hashtags, URLs, user mentions, or can be part of the text metadata, for example, author or media. Given the prevalence of NTUs, what are some of the challenges of incorporating NTUs in existing language models? First, we find that NTUs embedded in text are often split into multiple tokens, which can lead to diluted NTU-based signal. Second, existing language models do not incorporate any non-embedded NTUs. And finally, NTUs are characterized by their global context and relationship to other NTUs, and hence should be modeled appropriately. In social linguistic literature, it has been highlighted that the influence of social context around language is important. Ignoring these social contexts may lead to suboptimal language representations. Hence, our goal is to utilize NTUs in building richer social media post representations, which go beyond just their text content. We suggest a simple approach of concatenating NTU embeddings with existing token embeddings of a language model. These NTU embeddings are derived from the heterogeneous network of NTUs across the social media platform. Now, we highlight the key ingredients of our NTULM framework. It consists of a knowledge graph embedding phase, an NTU-enriched language model pre-training phase, and a downstream evaluation phase using frozen tweet embeddings. For the knowledge graph embedding phase, we limit ourselves to the Twitter user and hashtag graph. Since the user and hashtag can be connected in multiple ways, we consider authored, co-mentioned, favorited edges between a user and hashtag. For training our NTU embeddings, we utilize the TWIN framework for training large-scale knowledge graph embeddings. Next, we train NTULM using average NTU embeddings in a tweet. Ensure that NTU embeddings are in the same space as the token embeddings using a projection layer. For out-of-vocabulary NTUs or tweets with no NTUs, we use the overall average NTU embedding as the input. Finally, NTULM is fine-tuned via the MLM objective or tokens similar to BERT. For experiments, we consider the following datasets: a large-scale user hashtag heterogeneous graph for learning NTU embeddings, 1 million tweets for training NTULM via MLM objective, and a variety of classification tasks for downstream evaluation. First, we showcase the performance of NTULM on the MLM task as measured via perplexity on a held-out test bed. We observe that including NTUs in MLM leads to lower perplexity, with hashtags being most effective than user, and the combination of both NTUs being the best. Next, we use tweet representation from NTULM as input for downstream classification tasks. Here, our goal is to show that NTULM can act as a good general-purpose tweet encoder, which can be used out of the box without needing any more fine-tuning on the encoder side. Again, we observe that NTULM is effective and leads to better downstream performance compared to BERT, with a combination of NTUs being the most effective. Next, we investigate the performance of NTULM on tweets with and without any NTUs. First, we observe that our pre-computed NTU embeddings have high overlap with hashtags in downstream datasets. However, the overlap with users is significantly low. This may explain the ineffectiveness of NTULM plus author models. Next, we hypothesize that NTULM should be better in presence of NTUs, but should be similar to BERT when NTUs are absent. We validate our hypothesis first on topic prediction tasks and find that NTULM is much better than BERT for NTU overlap tweets, and is similar to BERT when NTUs are absent. This trend also holds across datasets, showing that NTULM representations are robust to the presence or absence of NTUs. Next, we investigate a common setup for including context alongside text. This setup, which we call BERT post concat or BERT-C, treats text and NTUs as separate features for the downstream model. We observe that NTULM is much better on most tasks compared to BERT-C. Furthermore, NTULM gains are even better on overlap and non-overlap slices of the data across most tasks, suggesting that BERT-C might be overfitting to the NTU signals. To recap, we have proposed NTULM, which allows integration of non-textual context into language models. We have demonstrated the effectiveness of NTULM as good out-of-the-box tweet encoder compared to BERT and BERT post-concat on a variety of classification datasets. And finally, we hypothesized that improving the coverage of NTUs in downstream datasets may actually help improve the performance of NTULM in future. If you have any questions about NTULM, please feel free to reach out to us or refer to our paper for more details. Thank you.